A circle is a set of all points equidistant from a given point called the center. The radius connects the center to a point on the circle, and then a diameter goes through the center. A central angle is made up of two radii. So it's an angle. An arc is the outside part of a circle. So this is a minor arc, it's less than 180, and a major arc is 180. A semicircle is halfway around. So if you name minor arcs, so name some minor arcs. Arcs have two letters if they're minor, so two letters, and you need to have an arc symbol above it, like this. Another arc that's a minor arc is BC, AC, AD, and you can also switch the letters around. So you could write DB, it's the same arc. Major arcs need three letters. So DBA would be a major arc. DBA, DAB. You could write down DAB, the arc. And let's see. DBA, I already have DBA. BAC. See, BAC would go this way, but if I want BCA, it'd go that way. So BAC is a major arc. Okay, semicircles. So semicircles are three letters, and they need to make a 180. So BDA is one arc, one semicircle, sorry, and then BCA, and there's more. That's what I'm going to do. Two adjacent arcs, so arcs that are right next to each other. So there would be consecutive. So I'm going to erase this. So an arc would be BCA, or BC is adjacent to AC. And there's a whole bunch of pairs. Okay, then finding arc measures. So the arc measure is the same as the central angle. So if AD is 140, so I'm going to draw in, if this is 140 degrees, then what is BD? Well, these have to add up to 180. So BD has to be 40 degrees. Make sure you put a degree symbol. Okay, then let's find measures of arcs. So I'm going to before I find these different arc measures, I'm going to go in and fill in the circle. So this has to be 50 degrees. This is 90. This is 90. This would have to be 140. This way would be 90 plus 130, which is 220. So then all the way around is 360. So now let's answer them. So arc AE, this has to be 90. So you're right, 90 degrees. Arc ED, we did, that's 50 degrees. Arc DBA is 130 plus 90, which is 220 degrees. Arc AED. Well, that's weird. That's weird that they put three letters in here, because really this would just be arc AD. So this is 130 degrees, or 140 degrees, oops. And then ABD is 220 degrees. And then BD is 130. So I don't know why the book did this one when this is technically not a major arc, it's a minor arc, but they put three letters. So you should also know the circumference of a circle. It's diameter times pi. So the circumference is the perimeter of a circle, so the distance around the circle. Or you can do 2r pi, same thing, because twice the radius is the diameter. So if we know the diameter is 5, then the radius has to be half that. So the circumference is 5 pi. If we know the radius is 6 and the diameter is 12, the circumference is 12 pi. If the circumference is 10, then 10 has to be the diameter and the radius is 5. And then 20 pi, this would be 20 and this would be 10. Another definition is concentric circles. So concentric circles have the same center. These are concentric circles. Alright, then a couple word problems here. A car has a turning radius of 16.1 feet. The distance between the front tires is 4.7 feet. In completing the outer turning circle, how much farther does a tire travel than a tire on the concentric inner circle? So we're talking about concentric circles. So then you're going to have, these are concentric circles right here. The distance between the two front tires, so is 4.7 feet. And the car's turning radius. Actually, I think the turning radius goes to the inside. So I think this is 16.1 feet. So what we're going to do is we're going to find the circumference of the inside tire, the turning radius, and the circumference of the outside turning radius, or outside wheel, and it says, it reads how much farther, so we're going to subtract the two distances. So I'm going to do, if the radius is 16.1, the diameter is 32.2 feet, so it's 32.2 pi is the inside tire, and the outside tire is going to be, add 16.1 to that. So that's going to be 20.8 feet a radius. So the diameter is 41.6. So 41.6 pi. So how much farther is, you're going to subtract these two. And since we're talking about a real life, you actually want to put it in your calculator and approximate. So this would be exact, subtracting them, but you actually want to have an actual number in your calculator. Okay, then number 4, the diameter of a bicycle wheel is 22 inches. To the nearest whole number, how many revolutions, so revolutions is circles, does the wheel make when the bicycle travels 100 feet? So you need to first find the circumference, which is 22 pi. That's the distance around. Now this is 100 feet. So I'm going to change 100 feet to inches. So this is 1200 inches. So you're going to take 1200 inches and divide it by the circumference. So it's going to be how many of these circles are going to go into 1200 inches. So then you're going to want to round this to the nearest whole number. And your answer would be in revolutions. So blank revolutions. Okay, next part, we won't leave much space right here, for the arc length formula. So we're not finding the degrees, we're actually finding the length. So we're going to find the length of this arc. So the length is dependent not only on the angle, but it's also dependent on the size of the circle. So what you do is you take the degree, or the arc measure, out of 360. So how much of the circle are you talking about? And you multiply it by the circumference. So for arc AB, we're talking about a 90-degree central angle. So you're going to do 90 over 360, and then you're going to multiply it by the circumference. So think about this blue part as basically being 1/4 of the circumference. This fraction reduces to 1/4. So it's 1/4 times, and then our diameter is 24, so it's 24 pi. So the exact is 6 pi, and my units are inches. So exact you keep in terms of pi. To the nearest inch, what you need to do is put that in your calculator. So put 6 pi in your calculator and then round it. I don't have my calculator here. So next one is the arc CDE, the length of the arc. So this degree of the arc is everything around a circle but 40 degrees. So 360 minus 40 is 320. So it's 320 over 360 times 2 pi r. So it's going to be 18 pi. Now we need to reduce and simplify. So 18 over 36 simplifies to 1/2. 32 divided by 2 is 16. So it's 16 pi centimeters. Now nearest centimeter is, put this in your calculator and round it so it doesn't have a decimal. This is exact, it has pi. And then FH, this arc right here. So if this is 90 degrees central angle and this is 140, the whole thing is 135. So do 135 divided by 360 and then multiply it by their circumference, which is going to be 6 pi. Now I'm going to see what I can cross off. So 6 divided by 36 is 1/6. So this is 1/60th. So then 135 divided by 60. This reduces to 9/4 pi. 9/4 pi. Okay, so to the nearest meter, you need to put this in your calculator and then round to the nearest meter. So in all of these, we don't have decimals. I know these two wouldn't be decimals, but reduce it to a fraction in terms of pi.